Hello everyone, my name is Praveen and today our group 14 will be presenting our project on the brain tumor image classification using the feature extraction and the KNN. So it's actually an MRI classification using the handcrafted features and the custom K nearest the neighbor classifier. So this project was completed entirely in the MATLAB, so without using any toolboxes, so which was one of the main constraints for the course. We will walk through the motivation, the system pipeline, the feature extraction process, and finally our experimental results and also the demo as well. So the brain tumor detection is an extremely important task in the medical imaging because the early diagnosis significantly improves the patient outcomes. So the manual interpretation of the MRI scans requires the expert radiologist and is time consuming as well. So the motivation behind our work is to build a simple reproducible system that can automatically classify the MRI images. So most existing research uses the deep learnings, but CNNs requires a large data sets, GPUs and the toolboxes, so which we are not allowed to use this one. So we explored the classical image analysis techniques and built a toolbox-free pipeline based entirely on the handcrafted features. So the deep learning is extremely powerful, but it has the limitations. It requires a lot of compute, lacks of interpretability, and depends heavily on the toolboxes. The classic ML approaches use interpretable features, run on low compute, and are easier to reproduce. From the literature, GLCM texture, descriptors, histogram features, and shape metrics are widely used in the biomedical image analysis. So this guide our section of the 28 handcrafted features used in the project. So for our experiment, we used the brain tumor MRI datasets from the Kaggle. It contains of a 7023 MRI images categorized into the 4 classes: glioma, meningioma, and pituitary and the node tumor. So this was the datasets, and these are the 4 different kinds of the categories, so which we use for this one. So here is the full pipeline. So we starts with an input MRI image and apply the manually pre-processing, resizing, grayscale conversion and noise reduction. So next we perform the feature extraction using a manual implementation of the Otsu thresholding to isolate the tumor region. We then extracted the 28 handcrafted features covering the intensity, texture, histogram statistics and shape. Finally, we classify using the custom KNN implementation and evaluate with a 5-fold cross validation from the MRI image to final prediction. So all pre-processing steps were coded manually, including a 3x3 averaging filter, using the conversion to grayscale conversion, using the luminance formula and normalization to the range 0 to 1. So this ensures the consistency across the dataset and keeps everything fully the toolbox free. So we use 4 major types of the features. The intensity feature captures the overall brightness distribution The texture feature comes from a manually constructed GLCM like matrix with innate level quantized image. The histogram features gives a compact description of the intensity distribution, and shape features are derived from the segmented tumor mask, using the mask perimeter, area, eccentricity and circularity. So these handcrafted feature gives us the interpretable signals for the classification. So in a multi-class setting, we evaluate the k values from 1 to 9 using the Euclidean and the cosine distances. So all training and the testing is done using a 5-fold cross validations to ensure the stable performance measurements. So this is the confusion matrix for a 4-class classification problem. We can see the strong performance for the pituitary and no tumor classes, but for the pituitary and the no tumor classes, but the model struggles with the glioma and meningoglioma. So this makes sense because these two tumor types often have very similar texture and the intensity patterns in the grayscale MRI, so making them the difficult to separate using the handcrafted features. So in the binary setup, so we combine all the tumor classes into one. So this reduces the complexity of the problem and increases the separability. So our binary classification results are extremely strong. The confusion matrix shows a very few false positives and almost no false negatives. The binary detection works well because the presence of or absence of a mass creates strong differences in the shape, contrast and the texture, which handcrafted features can easily capture. So the binary accuracy remains the consistent high across all the 5 folds between 98% and the 99%. So the multi-class accuracy also remains the stable, fluctuating around 79 to 82%. So this confirms that our feature engineering and the evaluation steps are reliable. So there were the 3 key challenges which we faced. The first one is a multi-class classification is inherently difficult because of the overlapping tumor appearances. Second, the segmentation without the toolbox functions can be noisy, so which affects the shape features. And the third, the KNN is sensitive to noisy features and relies heavily on the good feature engineering. So these limitations helped us understand like where the classical ML succeeds and where it struggles. So let's see a quick demo version. So let me quickly show you how the system works end to end. So here we are providing the input MRIs. So as I showed in the earlier, so input dataset which we are feeding. So firstly we are pre-processing. So let me run this one. So firstly we are applying the pre-processing. So resizing, grayscale conversion and the smoothing. So then we segment using the manual OTSU method to isolate the tumor region. So next our 28 handcrafted features are extracted. Finally the feature vector is passed to our KNN classifier and we obtain the predicted tumor class. So this entire pipeline is implemented using the only base MATLAB, so no toolboxes were used. So once this is completed, we can see the results over here, so where it is generated. Okay. So as the time is constrained, so I'm quickly wrapping up the things. So these were the references which which has played a crucial role in our project and which we use it to implement in our project. And in order to conclude, so we built a complete the toolbox free classification system for the brain tumor. For the brain tumor using the classical image analysis techniques, so we achieved 98.31% of the accuracy in the binary detection and 81.13% is in the multi-class problem. So this shows that handcrafted features remains useful, especially especially when the computational resources are limited. For the future work, we would like to add the PCA based feature reduction, exploring the morphological segmentation, improve and compare the KNN against the other classifiers such as SVM. If the toolbox is allowed, we could also benchmark against the CMM for the comparisons. So thank you for the listening. I will be happy to take any of the questions. If you have, please post in the comment section or directly reach out to us. So thank you again for the listening to the session. So I'm just going through all the slides, so just to make sure like everything is you feel everything is good. So please let us know if you have any questions. So post a comment and we'll be happy to help you reach out, answer your queries.